Julian was first. What is our objective today, Julian?
To use the law of cosines to find missing angles and side lengths of triangles with no right angle.
There it is. Thank you. And if you can't tell, we are on lesson 5-8. Write your name and date. Some of you, I'm not going to call out names, when I look at your binder, literally every single one of your notes doesn't have your name on it, and typically that person also doesn't have their name on the binder. I don't know who you are. Put your name right now on your notes. So eventually I'll flip on 5-8 and I'll be like, oh, that was the date that I told them to put their name, and they actually listened. Most of you are doing a good job though, so keep it up. Yeah, today's date is Thursday, February 6, 2020. So we have two kind of hard rules when it comes to non-right triangles. For the majority of geometry and future lessons in Algebra 2, Pre-Calculus, AP Calculus, we're going to be dealing with right triangles. This is that one weird time where we deal with non-right triangles. So if you ever see a non-right triangle in my class, think law of sines, law of cosines, you got a 50% chance of getting it right. So, law of cosines is a little bit harder because there's the gigantic formula. You need to memorize it.
No. Oh my God. Why does this have to happen?
This formula can be rewritten in two more forms for a total of 3 forms. They're all the same equation. I'm gonna flip the letters around. So let's analyze what's happening with this equation right now. Lowercase letters mean side lengths. Capital letters mean angles. Check it out. Capital A and lowercase a, they're opposites. Capital B, lowercase b are opposites. Capital C, lowercase c opposites. We understand the diagram. That's typically how we write triangles in geometry, where lowercase letters are opposites of their angles. So if I have angle A, that's kind of the main thing that I'm looking at. If I have angle A, the only thing that's happening here is on the other side of the equation is capital A, and then lowercase a, and I never ever use those a's again. They're on opposite sides of the equation. Lowercase a, capital A, and it's always a cosine because it's called law of cosines. So hopefully I've had you memorize now lowercase a, capital A, which means if I come down here and change this to a lowercase b, you guys can shout out this is going to be capital A, B, C, D, E, F, G. I'm singing alphabet song. Okay. If this is a lowercase a, this is a capital A. So if I change this to a lowercase b, this will be a capital shout out. B. Okay. And then where these other numbers come from, they're the other side lengths that we haven't used. So if I'm talking about lowercase a, and that's kind of my starting point, the other 2 side lengths, the ones that are surrounding the angles, we're always surrounding the angle. The C and B that are surrounding this angle A are the ones that are going to be squared, added to each other, multiplied by each other, and 2, and then subtracted. So you're just going to have to get this formula memorized. Let me show you the other 2 forms of this, and you're going to help me. But make sure you understand, for this general equation, if I start with angle A, then I'm doing the opposite on the other side, and then the side lengths C and B that surround my angle are that kind of middle segment right here. Know that they're squared, multiplied with 2. All right, so the other kind of cool thing to point out is this. What happens if A is a 90-degree angle? You guys don't know this yet, but cosine of 90 invalid is 0. That means 0 times 2bc is 0, which means I'm now left with, get rid of all of this, I'm left with
syntax error. Sign.
If I change this to a squared plus b squared is equal to c squared, does that sound familiar at all?
Oh my God, yeah.
Theorem of Pythagorean.
This is Pythagorean theorem, but with a twist, we're subtracting this additional 2bc times cosine of a because it's a non-right triangle. It shouldn't really be called the law of cosines. It should really be called the actual Pythagorean theorem for all triangles, not just right triangles. This is a more powerful version of the Pythagorean theorem. Let's see another form now. I'm going to choose B. So I'm going to change this to cosine of angle B. If I'm looking at angle B right here, My opposite always goes on the opposite side of the equation as well. So quiet raised hand. We're going to get lots of quiet raised hands to fill in these formulas. What should my letter be on the left-hand side of the equal to sign, Monse?
B squared.
It should be b squared. And we can just say the letter. We don't have to say uppercase or lowercase because the only uppercase is the one that I'm going to be saying. All right, what happens with these squares? What should I have squared plus what squared? What are the two numbers that fill in these boxes right now? Josie?
A squared plus C squared.
A squared and C squared, perfect. And then minus what, Gunnar?
2AC.
2AC, exactly. I just copied down those same letters, A and C. All right, let's try another one. Now I'm going to change this to cosine of capital C. All these are going to be lowercase. What goes on the far left-hand side, quiet raised hand, of the equation? You should turn in your card, Josie. Don't pull an Andres. Yeah, come on.
C squared.
It is indeed a C squared. What about these two squares right here? What goes in the place of those two C squares? Yeah, Gunnar.
B squared or A squared and B squared. That's good.
A squared and B squared. Wait, some of you are participating multiple times. Give me your cards.
I actually pulled it off though.
You did.
Let's see sure.
You've broken my trust now. Minus what? What goes here? What is being multiplied by this cosine of capital C? Who has their card? Raise your hand with your card if you have it. Jose, yes.
2AB.
2AB. Yeah, the AB and AB match each other. All right, so these are the three different forms that you could have. Use whichever one makes sense. So if you label your triangle with random letters, you still will be able to use one of these triangles. All right, so when do we ever use these things? And I didn't really talk about this last lesson. I'm fixing that for next year. There's two cases for using law of sines, and the notes have been updated if you go look at the website. And there's two cases for law of cosines. But generally speaking, if you kind of consider your unknown a thing that you're going to be using in your formula, the things that we're looking at are an angle in between two side lengths and an opposite. An angle in between two side lengths and an opposite of that angle. Depending on what I change to be the question mark will affect how you solve the problem. I can either have the question mark on the opposite side, or I can have the question mark on the angle that's in between. If I change the 31 or the 28 to a question mark, that changes it into law of sines. But these are the two different types of diagrams that will automatically mean law of cosines. That doesn't matter for today. I can ignore this information and I'll still be able to do the homework 100% because I'm only giving you law of cosines. Tomorrow, I'm going to be giving you both law of sines and law of cosines and word problems, and you have to be able to decide. You will have to be able to decide which one do I use. Do I use law of cosines or law of sines? Generally speaking, don't use math. Generally speaking, what you should be doing is, well, try one, and if it doesn't work, then try the other, then that one will work. But if you are smart, then you'll be able to see, oh, I have an angle in between two side lengths and an opposite one. Maybe one of these is x, or one of them is theta, and then that will mean law of cosines. I've talked too much about this already. Let's move on to example one. Let's actually use the darn thing, the formula. Here we go. I want to find line segment BC. So here's B, here's C. We're trying to find this length. Label it x. Label it with me. And I need another quiet raised hand, and it's going to be kind of hard. Fill in the formula. What squared is equal to what squared plus what squared minus 2 times what times cosine of what? There's lots of what's to fill in. First of all, I like starting with my angle, so I'm going to do cosine of my angle on the far right. That's kind of how I always start the problems. You don't have to do it this way, though. This is how I like to start it because it makes the most sense to me. Cosine of what angle? Well, I'm only given what angle? One angle, so what is that angle with the quiet raised hand? This is easy to get in here. Yeah, Jenny.
46.
Indeed, it is 46. And then on the very other side, I should be having a what? I'm looking for people that still have their cards to get in here. What should be on the other side of the equal to sign? Fernando. On the opposite side of the equal to sign, I have the opposite of the angle.
X squared.
It is indeed x squared. Everyone write it down with us. X squared. And then I'm using the other two things that I haven't used, 9 and 7. Somehow squared, somehow multiplied by 2 and then subtracted. Who can fill in all of this middle portion for us? It's going to have lots of 9s and 7s. Yeah, Gunnar.
9 squared plus 7 squared. And then 2
2 minus 7?
9.
2 times 9 times 7 times. All 4 of these things are being multiplied together. 2 times 9 times 7 times cosine 46. And we're missing one tiny thing, Gunnar. Do you see it?
Subtract 2 times 9 to 7 from the other end.
Right there. All right, there it is. We have filled in the formula. And that is generally the hardest part, because now that we have the formula, you should have lots of practice of being like, oh, I know how to solve equations, even with trigonometry now. So let's do some simplification. Let's get lots of people in. I'm going to leave x squared on the left-hand side. I'm going to try to simplify this up on the right-hand side. The very, very last step that we're going to do is square root. That's going to be the last step that we do. First, let's square 9 and 7. Who's got 9 squared and 7 squared? Individually. Jose. 81 and 49. All right, what about 9 times 7, and then on top of that, times 2. So first, what's 9 times 7? And then multiply by 2. Who's got that with quiet raised hand? 9 times 7 is blah. And then blah.
Wait, what?
What? I'm trying to figure out 2 times 9 times 7. You can do 2 times 9 if you like to do 18 times 7. Personally, I like 9 times 7 first. Yeah, Fernando?
126.
It is indeed 126. It is 126 because 9 times 7 is 63. 6 doubled is 12. 3 doubled is 6. So 126 is double 63. And then that is still going to be multiplied by cosine of 46. That hasn't moved anywhere yet. All right, and now I kind of just have to enter this on my calculator. Technically, I could just enter this whole first line on my calculator. I'm going to simplify one more step for us. I'm going to add 81 and 49. Well, 8 and 4 is 12. But I have to do the 1 and 9, which adds up to 10, so I'm going to make this a 13, so 130. 130 minus 126 cosine of 46. That's as simple as I can get it without touching the calculator. Now I have to enter it into the calculator. I might as well just take the square root at the very last step. Sergio, a question?
So you can skip those 2 steps and just put it into the calculator?
You could skip a few. I'll show you where to skip at the very end, but if you're smart, not if you're smart, that's the wrong way of phrasing it. If you're crafty and if you're tricky, I guess, you'll be able to solve it all in one step. All in one giant chunk. So the final thing that I'm going to do to isolate x is to do what to both sides? Quiet raise hand. Who's got this? Jessica. How do I undo a square?
Square root.
There it is. Square root both sides. And the final thing that I'm going to enter in my calculator is this. X is equal to, it's going to be the square root of all this stuff. I'm going to write that at the very end. 130 minus 126 cosine of 46, and parentheses, that's a bad 6. I can write that slightly neater. Oh my gosh. 6. And then square root the whole lot of those. And if I type that into my calculator, I have my answer. And I need to round to the nearest tenth. That means 1 decimal. All right, so x is equal to, question, Andres?
Could you technically just like from the first step just put that all in the calculator? Will you get the final answer just by doing that?
Yes.
So you don't even have to do these steps?
Nope, I just want to show you how to simplify. And now that you guys know Andres' shortcut, and I'm sure some of you have figured that out as well, yeah, you can just use that shortcut. I'll show you both the long way, well, I showed you the long way, and I'm going to show you the shortcutty way. But the shortcutty way does not work with one of the other types of problems. So in example 2, there's not really a good shortcut like there is for example 1. So let me enter this thing. So square root of 130 minus 130 minus 126 times cosine of 46. Cosine of 46. And the answer is, everyone write it down. We're rounding to 1 decimal place, so I'm going to round this 5 either up or stay the same. Who's going to round that for us? Sergio, yes. It is indeed 6.5. So x is equal to 6.5. So what is the shortcut? I don't want to do all that work, Mr. Sindel. Well, the shortcut would be at the very, very beginning, take the square root then. Let's see what happens if I do that. If I take the square root at the beginning, and you can write that down in your notes if you want to use a shortcut. I'm not going to write it down in my notes because I like showing all of my work. I could have just done this. Square root of 9 squared. 9 squared plus 7 squared minus 9 times 7 times cosine of 46.
2 times 9 times 7.
Yeah, there should be a 2 in there. Thank you. Teacher error. Log it. And I get the same exact answer. I could have done it from the very beginning. And an additional hint is, I think a lot of people are going to really love me for this, hopefully, is this. And you guys can totally try this out on your own. You can have your laptops open while I'm talking. Check this out. Square root. Oop, I don't know why I did that. I'm used to Microsoft Word where you have to do the backslash. But square root of a squared plus b squared minus 2 times a times b times cosine of, I don't know, we'll call it c. Why not? I'm just going to leave that there. If I have a is equal to 9, b is equal to 7, and c is equal to, what was our angle? 46. 46. I can leave, and it's kind of hard because I zoomed in so much, but if I zoom out a little bit, I can enter, so all these are the same answer, right? I can enter any numbers I want in here, change that to 8, and I have a new answer. Change that to 1, I have a new answer. Change this angle to 38, and I have a new answer right here, all in one line. I don't even need these other lines. I can get rid of them. Those are inferior to the ones that I'm writing. I can change these numbers, and my equation works either way. Although I'm showing you this hint, I might regret it. We'll see. I might never teach this next year. But it is kind of cool. It's a shortcut to doing your work. But it won't work for example number 2 unless you're really, really, really crafty. Question, Andres.
So, for the top one?
Yes.
A squared plus... Wait, do you have to use cos c or not? Cosine c?
Are you asking, could you use like sine of c or?
No. I mean, do you have to do c?
Oh no, you could change this to a number like
You do
38.
46?
Yeah, you could put 46 there if you wanted. But it just means if I want to change this again, I have to come back here and type over it. Yeah, so you could do whatever you want. So I could get rid of this variable. I don't need no third variable. And I could just change this manually, say 89.
But to get the answer for example 1, would you have to use c?
No. You could enter in the number 46. Like that. You don't have to say c is equal to that value. I was just showing you how to use all this with purely variables.
Wait, but that's not the answer.
Well, now I've changed this to 4 and 9. What was it? 6 point, what was it? 4, no, it was 9 and 7. 9 and 7, 6.5. Yeah, so I can change this just to 46, or I can change that to a variable c and then set c equal to 46. I'll get the same answer either way. All right, on to example number 2. You have a question?
So type, I don't know, but I think that one's wrong. So I don't know what that means.
We're gonna stop being such a squirrely.
9 squared, it should be plus right there. Not times, yeah. All right, so let's go on to example 2. Example 2 is the hardest type of question I can ask when it comes to cosines, law of cosines, because there's more steps involved. All right, so first of all, what are we trying to find? We're trying to find the measure of angle C. So here's C. I'm going to call that C. It's just the measure of C. I want to find what that C is. So I'm going to first do my equation. I'm going to say, okay, cosine of that angle, capital C, and I'm going to have an equal to sign on the very far left. What number should I have? Is everyone in? I think everyone is in. Yes, all right. Jose. Guys, if we could please listen to Jose's answer.
7 squared.
7 squared. It is indeed the opposite squared. Thank you. What about these two numbers, here and here? What plus what? I kind of gave away too much. Gunner again, yes.
6, wait. It's 3 squared plus 6 squared.
Yeah, it doesn't matter the order. I can say 6 squared plus 3 squared, or 3 squared plus 6 squared. I will get the same answer because the commutative property of addition says I'm allowed to switch those. And then finally, what happens right here? Another quiet raised hand. The same people over and over? Nope, I'm not okay with that. Sorry, Gunner. Sorry, Jose. I'm going to call someone else. I need more people in here, even though everyone's been in once. I need them all in twice now. Maybe I should give you each 2 participation cards. Julian.
Okay. 2 minus 2 times 6 times 3.
There it is. Thank you, Julian. All 3 of you have helped to set up our equation, and now we need to solve for that capital C, which means I have to throw every single one of these numbers over to the left-hand side. All right, let's do this. First, I'm going to subtract. Well, let's square the 6 and 3. Let's do it out the long way, and I'll show you a very kind of tricky shortcutty way at the very end if you want it, I guess. So 6 squared. Quiet raised hand. 6 squared. Jose. 3 squared, quiet raised hand. I'm just gonna start cold calling on people. Josie, yes, 3 squared. 3 times 3. 9, perfect. Minus, what is 2 times 6 times 3? Cohen again. 2 times 6 times 3. Well, 2 times 3 is what?
6. 36.
There it is, 36. Minus 36 cosine of capital C. All right, and that's equal to, what's on the left-hand side, Jenny?
7 squared.
Yep, what is that? What is 7 times 7?
49.
49, beautiful. All right, 49, and now I'm going to subtract, well, I guess I can combine like terms here. 36 plus 9, what is that? Jessica, 36 plus 9.
45.
45, thank you. Minus 36 cosine of capital C is equal to 49 on the left-hand side. I'm just simplifying step by step by step. I can't really simplify the right-hand side anymore, so now it's time to go with reverse PEMDAS and undo things that are happening to C. So reverse PEMDAS states, let's first get rid of any addition or subtraction happening. Well, I have subtraction of all that stuff, but I'm really saying get rid of that 45. That's the thing that's being, I'm doing 45 minus all that. So how do I get rid of 45? What do I do to both sides? Who's got this? Jose? Minus 45 on both sides. Minus 45, minus 45. And I'm left with now 4 is equal to, 45 is gone. I still have a negative 36 cosine of capital C. All right, well next I need to get rid of the multiplication that's happening. Negative 36 is being multiplied by cosine of capital C. So, how would I do that? How do I undo multiply by negative 36? Monse?
Divide by -36.
There it is. Divide both sides by negative 36. And that negative 36 should cancel out. I'm left with, ooh, we should be able to reduce this. Anyone want to reduce this for us? 4 over negative 36 reduces to, quiet raised hand, Fernando.
No, negative 9.
Careful, negative 1 over 9. So this is going to be,
Oh, negative 1, yeah.
yeah, negative 1 over 9 is equal, because we divided by 4, divided by 4. And that's equal to cosine of capital C. And then our final step, antiderivative, or not antiderivative, anti-cosine. How do I say anti-cosine? There's a word for that. Gunnar?
Arc cosine.
Yeah, arc cosine of both sides. And the arc cosine will cancel out with the cosine, and I now have isolated capital C. Capital C is cosine to the negative 1, or arc cosine of negative 1/9. Lots and lots of math, a lot harder than the last problem. And let's type in our answer into Desmos. So I'll say arc cosine of negative 1 over 9. And I get 96.3793721, but what am I rounding to? The nearest whole degree. So I need to round to the nearest whole degree, which means I'm going to round right there. Who can round this correctly for us? Is it 96 or 97? Andres?
96.
It is indeed 96 because that last number was less than 5. So we're going to say C here, capital C. We'll do it in red because red is our answer. C is equal to 96 degrees. 96 degrees in box it. So I think that there are people in here that can solve this problem. I think most of us can solve this problem. What would happen? How do I ask this question correctly? How do I get this same type of question where I can just use variables and just type in numbers and get my answer? How would I do that? Well, first I would have to subtract by a squared. I'll give you the first few steps and let you think if you can figure it out. I basically need to solve for this equation up here. If I have that equation and solve for cosine of a, what would I do first? Well, first I would have a squared, and I would minus b squared and minus c squared on both sides, and that would be left with minus 2bc times cosine of capital A. You keep doing steps and keep doing steps, and eventually you'll get a is equal to a formula that you can type into Desmos, and then you can just have your variables set equal to each other. So essentially what you could have is on a second line down here, you could have some sort of arc cosine of things happening with A, B, and C. That's not the formula. A, B, and C. And no matter what values I do for A, B, and C, I'm solving for both those two types of problems now. So you can create a Desmos calculator that has both the equations to solve the only two types of questions I'll be asking for law of cosines. The only two types of questions that exist for law of cosines. You've now created two perfect equations, and you don't have to do any more math after you do the initial amount of math. So do a bunch of work to do it with variables, but then that means less work for you down the road. Question, Sergio.
How are we going to use it in real life?
How are you going to use the law of cosines in real life?
Walking your dog?
You definitely not while walking your dog. It usually is used in construction. Like if I have to have a special triangle, if I'm making a house. These law of cosines are definitely less useful than right triangles, because usually in construction you use right triangles. If you're calculating like areas of things, like if you're you're a pottery person. What is it? Is it a potter?
Potters?
If I say a potter, I think of like a Harry Potter. So
Harry Potter.
if you work with like shapes and you need to figure out, well, how much clay do I need to make in order to make this cool art sculpture? Or maybe you're thinking of, oh, I have this weird property that I'm working on as a landscaper, and I need to plant grass because I'm being paid to plant grass. How much grass do I need? Well, first I need to be able to calculate what's going on here.
Oh, really?
So it would be really, really easy. Maybe like, okay, here's a situation. Maybe I have some sort of swamp or some sort of immovable object where I can't calculate this area over here, but the property has all of these lengths. I need to figure out, like if I'm building a fence, I have an angle here, 2 lengths here. How do I calculate that last fence that I can't actually measure because there's a swamp blocking it?
Walk the swamp.
Yeah, just walk through the swamp. I mean, there are other practical answers, but you can solve them with math too.
I don't feel like it.
That's all I have for you guys. Please give me a fist of 5. How well can you use law of cosines in these two different cases? I'm seeing 4. I don't know what that is, Gunnar. 5, a 3, a 3, a 4, a 4, a 3, a 3, a 4, a 3, and Jenny a 4.
I have a question.
All right. Yes, question, Gunnar.
Alright, so case 2, if you arc cosine the whole thing at the beginning, what will you get?
Arc cosine everything at the very beginning.
Yeah.
Then you're gonna the arc cosine you can't distribute, so it's not gonna cancel out with this cosine. It's gonna be just kind of a gross function. You have to do other functions first. Get rid of all of this stuff first, and then take the arc cosine. Yeah. So again, I will repeat my challenge. My challenge for you, if you want to go above and beyond, and I know that most of you can do this. If you want to go above and beyond, try to get an equation that solves for that capital letter and put that in your calculator. That way you just can enter 3 variables and have the answer every single time. You can solve these homework problems like that. It'll be as easy as just entering in 3 numbers and then you have your answer. Try it. You have room in your notes. Try solving one of these. I gave you room right here. Try solving for a variable. If you can solve for it, enter it in your calculator, and then you have an easier way of solving Khan Academy. All right, that's all I have for you guys.